Alright guys, welcome to chemistry. I hope that you are ready for some review. You do still have a test tomorrow. So we're going to start with the bell work. So when preservatives are added to foods to give them a longer shelf life, which factor is slowing the reaction rate? So you're looking at the 4 factors that affect reaction rate. Okay, so you've got a couple of minutes to work on answering that question. Okay, hopefully you've had some time to look through the factors that affect reaction rate. As a reminder, the 4 are temperature, concentration, addition of a catalyst, and addition of an inhibitor. So let's go through these. If preservatives are added, they are added to preserve the food. Okay, we want to give them a longer shelf life. So, if we look at temperature, we want to look at, are we making them warmer? Are we making them colder? Or are we not changing the temperature at all? So in this, there is no temperature change because we're not making it hotter or colder. With concentration, you want to look at if you're adding more or less of the same type of food. So adding more food to the same volume would give you a higher concentration. Taking food away from that would give you a lower concentration. Because we're not changing the amount of food, it's not affecting concentration. Now, catalysts and inhibitors are something that are added to a reaction to either, in a catalyst, speed it up, or with an inhibitor, slow it down. So in the case of preservatives, we're trying to slow down the decomposition of the food. If we were to add a catalyst, that would speed up the decomposition, so it would actually give it a shorter shelf life. So in the case of this problem, we are adding an inhibitor. So preservatives are inhibitors. They inhibit the breakdown of food and therefore give them longer shelf lives. Okay, everyone should pull out their test review guide. We are going to go over it. Throughout this, after the end of each section, we will take a pause so that if you have questions, you can actually email me. Okay, and your substitute today, thank you for subbing, by the way, will be able to send an email to mrs.horn.fhs@gmail.com. And I will, as much as I can, respond immediately to whatever questions come up at the end of each of these sections. So let's start by taking a look at the first section in your review guide. If you don't have a review guide, we do have a couple of extra copies, so please let the sub know. So in the first section, we're looking at the different types of reaction types. Okay, and we have to not only define, but also write the AB equation. So let's start with the AB equation. So for synthesis, we have two things coming together to make one. So the AB equation would be A plus B yields AB. Okay. When you're looking at an easy-to-use definition, you would want to say it's two substances coming together to make one substance. All right, because what's happening is in this, the A and B, which could be elements or compounds, are reacting with each other and forming a single product. Okay, now the opposite of that would be decomposition, so our next one. So decomposition runs the opposite direction. So you start with AB, you start with a compound, and it decomposes or breaks down into A plus B. Okay, so in these, a simple way to put it is that you have one substance that's breaking down into two, and sometimes you can get more substances. So synthesis and decomposition are exact opposites. So synthesis, 2 to 1, decomposition, 1 to 2. Okay, single displacement gets a little more complicated, but with single displacement, you have an element reacting with a compound. And what happens is this element kind of kicks out one of the elements in the compound and takes its place. So then B ends up not in the compound anymore, and A does. Okay, when you're looking at this, an easy way to think of it is you're always going to have an element and a compound as your reactant, and you're going to have the same thing as a product. You're going to have a different element and a different compound. In double displacement, okay, it's very similar to single displacement, except that rather than just an element of compound, you end up with two compounds. So you end up with A, B, and C, D. And in this, the A and the C switch places. So in this, we're looking at ionic compounds, and the positive portions of the ionic compound switch places. So you end up with A bonding with D, and C bonding with B. So in these, you always start with compounds and end with compounds. Okay, and you always have two of each. Combustion is a very specific one. With combustion, you always have something reacting with oxygen. And you have to form carbon dioxide and water. If you don't see the CO2 plus H2O, you do not have combustion. It may be a different type. Okay, so you want to kind of write a note to yourself that you can start with just about any substance. Okay, it'll usually contain some carbon and hydrogen, and usually some oxygen. Okay, it has to combine with O2, but you have to form CO2 and H2O. Okay, if you don't have those two substances, and you may have more than those on the other side, depending on where you get your oxygen from, then it's not combustion. Okay, so this is where you get the flame, right? The oxygen makes things burn, forms carbon dioxide and water. All right, so please pause the video and write down any questions that you might have. send those questions to me, or actually give them to the substitute, and the substitute will email those to me, and I will answer them as quickly as I can. While you're waiting for that, okay, please take a look over these and see if you can answer each other's questions just by going through it. You're also going to use these in this next section, so take a minute to go through those, double check, okay, make sure you have everything written down for answers. If you don't, okay, write it down or put a little question mark where you might have a question, and we'll go over that part momentarily. So again, please pause and send out questions. Welcome back. Hopefully you got any questions that you had answered. Okay, so now we're going to take a look at number 2. Number 2 is actually made up of 2 parts. We need to classify and balance. Okay, I'm going to leave the balancing up to you because we've gone over that before. That should be pretty old school. Okay, just remember to look at each element individually. And if you have a specific question on how to balance one of these, you can ask that at the very end. Okay, or work with each other to see if you can figure it out. So let's go through each of these types. So if we look at A, what I'm going to do is I'm going to go through each type of reaction, and we're going to see whether or not, or give it a yay or a nay on what it is. So, in a synthesis reaction, right, you start with 2 and you end with 1. So we do start with 2, but we don't end with 1, so it's not synthesis. Okay, how about decomposition? Starting with 1 and ending with 2. Well, we already know that we start with 2, so it can't be decomp. Single displacement, you start with an element in a compound and you end with an element in a compound. So we have, on these, 2 compounds. So we know that it can't be single displacement because there's no element to displace another. Double displacement, you have 2 compounds, conveniently 2 compounds, yielding 2 compounds, and you've just kind of had a flip-flop of the elements. So if you look, the Ca on this side is bonded with the OH, but on this side is bonded with the SO4. And same for aluminum. On this side it's bonded with the SO4, on this side it's bonded with the OH. So that means that we've got a double displacement. And I'm just going to put D for double displacement. Alright, next one, let's go through again. So B. Synthesis, starting with 2 and ending with 1. Well, we start with 2, but we don't end with 1. Okay, decomposition, starting with 1, ending with 2. We already know we start with 2, not decomposition. Okay, single displacement, start with an element in a compound. Well, we've got that. C2H4 is a compound. O2 is oxygen, is an element. So let's go to the other side. Do we end with an element in a compound? Nope. We've got 2 compounds, so it's not single displacement. Okay, double displacement, because we've got this element here, we know it can't be double displacement, because those are compound, compound to compound, compound. So our last choice is combustion, and it's a substance bonding with oxygen to form carbon dioxide and water. So that's exactly what it is. So this one is combustion. I'm just going to put C-O-M-B, combustion. All right, C. Synthesis would be starting with 2 and ending with 1. Well, we start with 1, so it can't be synthesis. How about decomposition? Starting with 1 and ending with 2. Well, we started with 1. If we look over here, we end with 2 simpler substances. So this one is decomp, or decomposition. All right, D. Let's go through again. So synthesis, starting with 2. We do start with 2, ending with 1. Nope, we got 2 over there, so it can't be synthesis. Decomp, starting with 2, yep. Or I'm sorry, starting with 1. Nope, can't be it, so it's not decomposition. Single displacement, start with an element in a compound. Well, I2 is iodine, its element. NH3 is a compound. If we look over the other side, do we end with an element in a compound? We do. N2I6 and H2. So what's happened is the I's gone in and kicked out H. So this is a single displacement. Okay, and then the last one, let's go through. So synthesis, starting with 2, yes we do, ending with 1, absolutely. So this is a synthesis reaction. Okay, now, you're going to take a couple of minutes if you have not balanced these yet. please do. Okay, so you can do that. If you have any specific questions, okay, please make sure you let the sub know that. Okay, what I'd like you to do is take a couple of minutes and then come back. I'll show you what these are balanced so you can check your work. Okay, so these are your balanced equations. You might notice down here that there are no numbers. That's because this equation is already balanced. Okay, so double check yourself. Make sure that you have those all balanced correctly. Okay, and we can now move on to number 3. Okay, so let's pause the video. If you have any questions on this section, like I don't understand how you balance that, or why is it that type, I thought it was this type, okay, please ask those now and send me an email. Welcome back. Hopefully you got all your questions answered again. So let's take a look at now number 3. So list and explain/define the 4 factors that affect reaction rate. So we listed these already in the bell work. We have temperature, concentration, we have the addition of a catalyst, and the addition of an inhibitor. Okay, so let's define each. So with temperature, an increased temperature, right, gives us faster movement, which gives us a higher reaction rate. And the opposite is true as well. So if you have a lower temperature, you end up going slower, and you get a lower reaction rate. Okay, the same is true as concentration. If we increase the concentration, okay, that gives us more particles, and therefore more collisions, which leads to a higher reaction rate. So temperature and concentration, as they go up, reaction rate goes up. As they go down, reaction rate goes down. With catalysts and inhibitors, they're a little different. So catalysts are added to a reaction to speed it up. Okay, but they don't take part in the reaction. So they do it without reacting. Inhibitors are opposite. They inhibit or slow down the reaction, and also without taking part in the reaction. Okay, so you should be able to recognize when these are taking part. So for example, if I were to say meat in the freezer lasts longer than meat in the refrigerator, and then ask you which factor affects that, you'd have to go, okay, well, I'm not adding anything to it, so that means it's not a catalyst, it's not an inhibitor. It's the same meat, so I'm not changing the concentration, but I am making it colder by putting it in the freezer. So a decrease in temperature makes the particles move slower, decreases the reaction rate. Okay, so that's how you need to be able to use this kind of information. Okay, shouldn't be any huge questions on this, so we're just going to move straight forward into the next section. So, number 4, we're looking at shifting of reaction. So, as kind of a quick cheat sheet, reactions will shift to the same side of a removal. So if you remove something on the left, it'll shift left. If you remove something on the right, it'll shift right. Or it'll shift to the opposite side of an addition. So if you add something on the left, it'll shift right. If you add something on the right, it'll shift left. So let's look at this. If I remove iodine, that's right here. So I'm removing on the left, and since they shift to the same side of a removal, that means I'm going to shift left. And I'll just put an L for left. Okay, another removal. In this one, I'm removing heat, and heat is energy. So if I have less of that on the right, that means I'm going to shift right. Alright, so now let's do some additions. if I add hydrogen, okay, hydrogen is right here, that means I've got more of it on this side, and since it's going to shift to the opposite side of an addition, I'm adding it on the left, so it's going to shift right. Okay, with adding hydrogen iodide, right, hydrogen iodide is right here, and if I'm adding more of that, again, it shifts to the opposite side of an addition, so since I'm adding on the right, it's going to shift left. Okay, and this is true of all reactions. It's always either shifting to the same side if you remove and the opposite side if you add. All right, so let's take a look at the next reaction. So first, we're going to add some heat. And again, heat is energy. So if I add more of this, that means I've got more on the left. Since we shift to the opposite side, I'm going to shift to the right. Okay, if I remove sodium chloride, all right, sodium chloride is NaCl. If I get less of that on this side, I'm going to shift to the same side. Since I'm removing on the left, I will shift to the left. If I add sodium, sodium's right here. Okay, so if I'm getting more sodium on the right, I'm going to shift to the opposite side and go left. All right, and the last one is a removal. If I remove chlorine, all right, chlorine is right here. If I remove that, I'm removing on the right. It's going to shift to the opposite side, so it's going to shift left. Okay, and actually, can we go back to this? This is me switching my rights and my lefts. I'm sure you're going, Mrs. Horde, what are you doing? What are you doing? If I add this, it's on the right, and it's going to shift left. Oh, I had that. Yeah. I messed up this one. You guys are loving me right now, I'm sure. If I remove chlorine, it's on the right. It's going to shift to the same side. So this is going to shift right. You can't take me anywhere. Okay, so I hope you guys caught that mistake that I made as I was going through. I apologize. I mix up my left and my right on a pretty regular basis. Don't get directions from me. I'll probably send you all the way to Colorado. You're trying to get to Maine. So, that's that. Let's take a look at the next problem. If you have questions, which you might, because I screwed this one up, feel free to pause the video and have the sub send me an email. Okay, welcome back. We are on the next problem. What we're looking at here is doing a little bit of conversion. So what you're actually going to do by going through this problem is do a full-fledged stoichiometry problem. You'll see that there are lots of steps to it. So step one, we need to balance our equation. Okay, so let's go through and do that. Okay, so we've got N2 plus H2 yields NH3. So we're going to do those N's first. Okay, so I need a 2 over there to give me my 2 N's. And then I have 2 times 3 hydrogens over here, which is 6. So I need to have 6 hydrogens over here. So I take 2, I have to multiply that by 3. So that balances me out. So now my mole ratio is 1 to 3 to 2. And I'm going to use that farther down here on C. Okay, alright, next. I need the molar masses. So you're going to need, if you haven't done this already, your periodic tables and a calculator. Okay, so for N2, I take the mass of N, which is 14.01, and I multiply by 2. So my molar mass of N2 is 28.02. Feel free to check my math. Okay, for H2, I take the mass of H, 1.008, and I multiply by 2. So I get 2.016 grams. Now for NH3, I take the mass of 1N, 14.01, and I add to it the mass of 3 times H, 1.008. So I get 14.01 plus, let's see, 3.024. Okay, so my final mass is 17.024. Oh, sorry, 0.01, so 034. Okay, so now I've got all my molar masses. So my next step is to do a conversion. So in this case, I'm doing grams to moles. And when I do grams to moles, I'm going to divide by molar mass. So I take 48.6, and then I divide by, because I'm dealing with N2, the molar mass of N2. So I divide by 28.02. And I get 1.7344753. So we're going to round that to 1.73. Alright, so that's now moles of nitrogen. Okay, next up I have to use the mole ratio, which luckily I have right here, to determine how many moles of NH3. So that's where I'm going. Okay, I've got 1.73 moles of N2. I write my conversion factor. So I'm going from N2 to NH3, and I get my mole ratios. So I have 1 N2, so I put a 1 down here. I have 2 NH3, so I put a 2 up here. My N2s cross out. And then I just do 1.73 times 2, which comes out to be 3.46. And I divide it by 1, but it ends up being the same. And this is now moles of NH3. Okay, last step is now moles to grams. So when I did grams to moles, I divided by molar mass. So when I do moles to grams, I'm going to multiply by molar mass. So I take 3.46 and I multiply by the molar mass of NH3, which if we come up here is 17.034. So I multiply those two numbers and I get about 12. So 12.002, so on and so forth. So I'm going to put 12.0. And my units are grams of NH3. So you're going to have a problem exactly like this. Not with the same numbers, okay, but you're going to have to balance an equation, figure out the mole ratio, figure out molar masses of the substances involved, convert grams to moles, convert using mole ratio, and then convert moles to grams. Okay, so make sure you can do each of those things. Okay, if you have your periodic table, make sure you bring it with you for the test tomorrow. If you have your own calculator, again, you can't use iPods or cell phones or anything like that for calculators on tests. Okay, bring your calculator with you, otherwise you can use mine. Okay, so take a minute. If you have any questions on this, feel free to pause the video, and our wonderful substitute can send me your questions. So take a minute to do that, please. Welcome back. I'm hoping you got all your questions answered, or you're able to do it on your own. Hey, our last question is the inquiry question. This is the exact same. Exactly the same. This will be the same on your test. Okay, there will be nothing changed about this question except that it will now be graded because it's on your test. So let's read through this. Few biochemical reactions occurring in our cells reach equilibrium. So remember, equilibrium is when you have a reversible reaction and it just keeps going back and forth. You don't get any products, it just keeps going back and forth. Most of the time, it is to our advantage to almost completely form products from reactants. And now the question, so that was a little background. Would our cells get more energy from the exothermic combustion of glucose if the reaction goes to completion, which means it only forms products, or reaches equilibrium? So it reverses to reform reactants, and it reuses all the products to form those reactants. And then you need to explain. So this is your equation. It's either reversible or not, depending on what you determine. So let's take a look at this. So here's a cell. Yay, a cell. And it's got all the little thingies and the Golgi apparatus and a nucleus and, all sorts of stuff. Cell wall. Hope you remember back to bio. So, if I have this reaction and it does not go to completion, that means that I've got C6H12O6 plus O2. Okay, and that yields, and again, I'm not balancing this just for space, CO2 plus H2O plus heat. Okay, if it's reversible, all of that goes back to forming more oxygen and glucose, which means the cell gets nothing. Okay, we just took everything we possibly could away from the cell. So the cell gets no energy and it crumples up and dies. Okay, but if the reaction goes to completion, so if we get, we start with our C6H12O6, we add some oxygen, and we go completely to products, forming CO2 plus H2O plus heat. If we don't reverse it, okay, we know that the CO2 kind of floats off into the air. Okay, the H2O will end up in a lake or something like that. The heat can go into our cells, and then our cells get happy because they have energy and can go. So, you want to almost completely form all products. Okay, so our cells would get more energy from the exothermic combustion of glucose if the reaction goes to completion. Okay, so you should be able to explain what we just did down here. Please be able to do it in more than the diagram I gave you. Right, if you need to rewind and re-listen to this explanation, feel free to do that. This brings us to the end of our review. If you have any other questions, if anything comes up, you can, again, feel free to send me an email. You can do it on your own if you'd like. If you need to email me specifically, remember that my email is mrs.horn.fhs@gmail.com, and I will be checking this all day long. I am at some point today at the doctor's with Mr. Horn, so if I don't answer right away when you're emailing on your own time, don't worry, I will get to it soon. Alright, so have a wonderful rest of your day. Don't forget we have a test tomorrow. Okay, so study, study, study. Grab a study buddy. Find somebody, if you are unsure of what's going on, that knows what's going on, and team up with them. Okay. Or I have first block tomorrow, or before school. Either one works. So if you want to come in and ask a couple of questions, feel free to do that. Have a wonderful rest of your day, and I will see you tomorrow.